Unit 1 equations, and I call those the easy cheesy equations. Then we get into these three equations, which are called the Power Ranger superhero morph equations. What these are is those three equations manipulated and smushed into like a hybrid. So now this is a new acceleration, a new displacement, and a new displacement. I want to stop for a moment and I want to highlight this one. And the reason why I'm going to highlight it is because it is not on the formula chart. So I'm going to put a little arrow over here, not on formula chart. It's actually a memorized equation. Well, I want to show you though, on the actual formula chart, here it is. Here is my acceleration, my velocity. Here's my acceleration equation. Look at this. Here is my new acceleration equation. Here is my new displacement equation. But even though this one is not on the formula chart, all you have to do is if you were given a VF and not a VI, you're going to put the VF inside the VI and flip the addition over there to subtraction. That's all you're doing. So at least you still have this equation on your formula chart. But this one right here is a memorized equation. Turn the page when you're ready because we need to do some practice problems. Because homework number 1 is going to be practice problems like this, what we call kinematics. Then it says, okay, you've got your easy cheesy equations, but from here on out, my suggestion is to use this flow chart. Now, there's other physics classes in this classroom on Mondays and Wednesdays, and then they also have physics class for the P-Tech program that's in here. Different teachers, different students. I'm telling you right now, they do not teach them the flow chart. They just say, hey, 1, 2, 3 equations. I don't like that. This flow chart is amazing. Ask yourself the question, number 1, was displacement ever used? No? Then I'm going to use this equation. If the answer is yes, ask yourself question number 2. Was T ever used, talked about, or discussed? If the answer is no, then you're going to use this equation. If the answer is yes, ask yourself question number 3. I should have said this yesterday, but I guess I didn't. It's okay. Question number 3 is, was VI given to you or was VF given to you? That is question number 3. Because if VI was given to you, automatically use that equation. If there was no VI at all given to you, then this is your equation. But wait a minute, Miss Munson. What if they gave me both VI and VF? You still use the first equation. I'm telling you, my flow chart is amazing. It's not 100% perfect, but it's pretty darn good. So let's go ahead and let's do this question number 1. So on question number 1, it says over here, it says that a car accelerates uniformly from rest. VI is 0, right? Rest, it wasn't moving. To the speed of VF, 23.7, bless you. It took this much time, 6.5 seconds, for it to occur. Find the distance, question mark, of how far the car was traveling during this time period. Step 1, you're going to write down all of your variables, VI, VF, D, T, A. Those are my 5 variables. You're going to need those because in our notes next week, we're going to bump up to 8 variables. We're just adding. Right now, write your 5 variables to help organize your thoughts. Okay? Now, let's go ahead and remember it says up here, identify the variables that were given. Well, let's go ahead. VI is 0. VF is 23.7. T is 6.5. Distance is question mark because that is what I'm looking for. And please, you don't have to do this exactly like me, but I think it will be helpful. put an X on what you do not have. Because I need to distinguish what am I looking for and what do I not have. Now let's use our flow chart. Question number 1. Was D ever used, talked about, or discussed? Yes. It's my unknown variable. I'm looking for it. Okay? So go over here. Question number 2. Was T or time ever used, talked about, or discussed? Yes. So now, was VI given to me? Yes. That is my equation right here. Distance equals VI times T plus 1/2 AT squared. There we go. All right. Let's fit it. I agree now. Let's fit those numbers in. Because we know that for algebra, you have to have everything there except for one variable. So let's fill this in. Distance is my unknown. VI is 0. T, 6.5 plus, remember how I said we hate fractions in physics? Let's change that to a decimal. I agree, 0.5. Whoa, I put an X on A. A was never given to me. And T is 6.5, but look, do not forget to square it. I forgot to square it earlier today. Don't forget to square it. Okay, so algebraically, could I solve any equations while I'm missing 2 variables? No, I can't. But Miss Munson, you just got there talking how amazing your flow chart is. It is. This is the exact equation I'm going to use. How? Well, if I have a problem because I cannot solve it, then that means that it is a 2-step problem. So I need to solve for A first before I can figure out the distance. So let's do that. I'm going to come over here. I'm going to say number 1 because it's a 2-step problem. A equals VF minus VI over T. Or A equals, what was my VF? 23.7 minus 0 over 6.5. So again, I really think doing this practice problems is going to help us for homework number 1. Alrighty. So I can use this because I'm only missing 1 variable. And I'm telling you, look at that. My flow chart was like good. It really helped guide me. Double check my answers, but this is what I got last class period. I got A of 3.65 meters per second squared. Now, I'm going to pause for a moment because I get some students who get excited and they're like, oh, that's my answer. No, look over here. I have an X on A. That's not my answer. My actual question is looking for the distance. So let's come over here. Let's write 3.65. Let's come over here and let's write 3.65. And I love it when my VI is 0 because then 0 times anything is 0. Cancel that out. Distance equals, well, I like to do each part separately. So I'm going to say 0.5 times 3.65, and I'm going to square root this, or square it, which is 42.25. But just double check my math, but that's what I got earlier this morning.
And then just multiply all of those numbers.
I agree. Multiply all those numbers, and it's 77.11 meter. I get a little offended when people are like, physics is hard. You're taking that class. Yeah, you are. Look, it wasn't hard at all. That flow chart is going to help guide you. And again, for Unit 2 test, I think it's going to be a good resource to have in front of you. All righty. When you're ready, turn the page. Turn the page when you're ready. Because we do have homework number 1 next week on Monday night. And it's due for Tuesday. So let's turn the page. So do you remember where we stopped here? We stopped because I have students that mess up every single year on the orders of operation. That's the reason for that pop quiz yesterday. It wasn't really to torture you. It was to tell you, you know what? Please excuse my dear Aunt Sally. Let's do those parentheses first. Let's do our grouping first. Those parentheses. Please excuse exponent, my, multiplication, dear, division, aunt, addition, Sally, subtraction. You are smarter than the calculator. You need to make sure that you put in the correct order of operation on your calculator. Even though it's a calculator, you're smarter than it. So let's go ahead and let's do this. 0 squared, take away 0 is nothing. 2 times 4.75, okay. Well, we did this earlier today. I got 9.5. So I have 0.5 equals VF squared over 9.5. Okay, I need to find that VF squared. This is not going to cut it. So algebraically, hopefully you're saying, Miss Munson, times by 9.5, cancel, times by 9.5, that answer is 4.75. Done.
That's it?
Is it? Is it?
No,
Why not?
because you still have to start the whole time.
Where am I at missing? I like this problem. What am I missing?
4.75 divided by 9.5?
That's final velocity squared, and we're trying to find final velocity.
We're trying to find final velocity. I agree that we're not done yet, but please take a glance at that is square, so we need final velocity by itself, not a squared value. So you were definitely on that right track that we were not done yet. Hopefully we all can recall we've got to square root it, which is the opposite of square. So now VF by itself, because we square rooted that, comes out to 2.18 meters per second. Now we're done. Thank you, Carlos. You were so on the right path. We just needed to square root it. Okay? Again, this is some like math class that you've done before, math skills. Nothing crazy. Let's skip over Shelby, 4, 5, or 6. Any one of them. Okay, she says 5. And remember, we have homework next week on Monday, but we've got to practice today. Number 5 says that a truck pulls a trailer, okay, at a velocity of 23.61 meters per second. Okay, now at this moment, I do not know if it's VF or VI, so I just have a V. When they hit a bump on the road, the trailer detaches and the trailer decelerates at an acceleration of A, 1.13, north along the road. How far will the trailer travel before it comes to a stop? VF of 0, this is my VI. How far is the distance? Okay, we have to be able to read these word problems and identify those variables. It is a little tricky. And I'm telling you, those little math apps on your cell phone, they're not going to help you. You've got to be smarter than that. All right, so let's go ahead and let's take a glance. Step 1, VI, VF, T, A, D for distance. All righty, let's plug in our numbers. 23.61, 0. Whoa, T was never given to me. Put an X. 1.3 and question that distance. Okay, I have my flow chart a little memorized because I've been doing it for a while. Was distance ever used, talked about, discussed, looked for, given? Yes, that is my unknown. So I'm going to have to come over here to this side. Was T ever used, talked about, or discussed? No, I X'd it out. That is my equation that I'm going to use. Okay, flow chart. A equals VF square, oh, don't forget that, minus VI square over 2D. Okay, plug in your variables. Alrighty, we can do that. 1.3 equals 0 squared minus 23.61 squared over 2. We don't know D, but that's perfect because that's what we're looking for. And algebraically, I can only solve for one missing variable. I haven't done this one yet today, so let's do it together.
Isn't it minus 23 squared?
Say it again?
23 squared divided by 2D?
Yes. But what about that negative? Do you see why we did this orders of operation yesterday now? Because my question is that negative inside the parentheses? No. So we're going to do the parentheses first. I'm telling you, those orders of operation is important here in physics. So let's square it of 23.61. Oops. How do you use this calculator? Alrighty. 1.3 equals negative. Leave that negative out because it's outside of the parentheses. Square this, like Carlos said, of 557.43 over 2D. Okay, hey, we need some strong algebra skills here. Okay. What's the next step? I know what to do, but do you know what to do? Let's ask Mr. Shannon over there. He's over here coming in hot, making other students cry. What's your thoughts? Your opinion? What to do? I need to solve for distance, but it's attached or it has a 2 next to it. And it's at the bottom of the division. You can't solve for anything at the bottom of the division. It needs to go to the top. So what do you want me to do? Well, whatever step you want me to do. What do you want?
You get a detached from the D.
Or get it to the top. Yeah, but what's the next step? Man, Mr. always have a lot of words to say. I'm sorry.
Bullying.
Find the distance is what we're looking for. What's the next step?
Divide.
How can you divide? How are you going to divide something that's already?
Right, it's already divided.
Yeah.
Okay, we can add. Oh, I like the multiply. Who said multiply?
Jordan did.
Oh,
Sure did.
okay. Jordan says multiply. Multiply by what? 2 what? There you go.
Yes, sir.
Cancel that. Multiply this side by 2D.
And then it'd be
Okay. Now,
2.3.
2.3 like this? Okay, wait a minute. We've got 2.3, the letter D, and 1.3. They're all standing next to each other. Mathematically, what does that mean? They're all 3 being? What's that?
Combined?
How are they being combined? They're all being multiplied.
So
Okay.
it'd be 2.3D.
No.
Okay.
Multiply those numbers.
I'm using a calculator right now.
You're right, 2.3.
Okay.
So what Carlos did was he got 2 multiplied by 1.3, and it was 2.6 because this was multiplied by the 2. That's the only reason why. So I'm going to come right here, and I'm just going to write this step. 2.6D equals negative 557.43. Now, I just want to make sure that, number one, don't freak out if you see negatives. Again, orders of operations are super important in this class. If that negative is outside of the parentheses, leave it outside of the parentheses. Now, what'd you say?
Divide.
You said divide.
2.6.
I agree, by the 2.6. So we can isolate that distance by itself, divide 2.6, cancel. Distance is 557.43 divided by 2.6 equals, does the negative go away or does it stay? It does stay. Negative 214 point, I'm just going to round it up, 4 meters. Okay, and I want to pause here for a moment while some of us are writing this in. Let me try to scoot this up.
Miss, wants to ask a question. Is it okay for like a couple, like 10th and 100th away?
Oh, yeah. Because I am going to look at your steps to make sure, because these are the proper steps to use, those orders of operations, number one. Number two, here's what this was a good question Shelby gave us. Thank you for the challenge. Number two, do not freak out on negatives. We can have negatives in physics. Most of the time when we have a negative, it means, do we remember from Unit 1, what does a negative mean? The direction, because a vector, left or moving backwards, the opposite direction, if that makes sense. So is displacement a vector quantity? Yes. So it can have a negative. And look over here, let's read. It says the truck pulls a trailer when it hits a bump and the trailer detaches. If the trailer decelerates going north, it says here, how far will it travel before coming to a stop? So north, you would think traditionally would be a positive value, but if the trailer and truck are doing this, opposites, that's the reason why there's a negative value there. Because that negative value means that it detached opposite direction of what it was originally going. Look, it was going like this. The truck was going this way, and the trailer was attached. Look, it hit a bump, and it went like this. That's the reason for the negative. It detached, okay? So the negative was absolutely A-okay. But I read that, and I was like, oh, okay, the negative is acceptable. Okay, Shelby, you really got us in a good question right there. Other than that,